Is start greater than end? If this is the case, that means we could not find target. So you return what? -1. Correct? Next condition, you calculate mid now, which is start plus end minus start by 2. Okay. Now, 3 cases. There are 3 cases available. Whether nums mid is equals to target, correct? Either this condition, else if nums mid is less than okay, you have a condition. Let's write it later. Okay, if this is the condition, this is also a happy case. So I'm going to what return? I'm going to return mid. Okay, now let's figure out how can I find a particular element in the first or the second section. Okay, so let's figure out whether the first section is sorted or second. Okay, so first section sorted कैसे check करेंगे? अगर nums start is less than equals to nums mid है, इसका मतलब पहला section sorted है, correct? That means the first section is sorted. अगर ऐसा नहीं है, that means what? The second section is sorted. Correct? अब अगर मेरा पहला section sorted है, तो मुझे पता करना है कि whether my target is actually lying in the first sorted section or not. Correct? How can I check? If देखो, if start is greater than num start is greater than target and nums end target. Okay, if this is happening, my friends, if this is happening, this right, in that case what you do is you simply do return search from where and where? Nums start mid -1, because mid is not the solution in that case, and target is there. Okay, if this is not the case, if this is not happening, what you'll do is you'll return search nums mid +1 end and target. Correct Aji? Mid +1 and target. Similarly, my friends, this piece of code I'm going to copy and I'm going to paste it here. If the second section is sorted, you're going to search between what? Mid to end, correct? You're going to search between what? Mid to end. If mid to end is there, just change these values, my friends. It's going to be mid +1 and end. And this will become start to mid -1, correct? See how simple is it? Clear is it? Anyone who did not understand this part? Let me tell you how this is working. Okay, so let's look at from graphical perspective. So I have an array which is sorted. Okay, I cut some part of it and I make it in the start, right? That's what's happening. So it can look either like this, right? Either shoot, don't do that. Or it can look something like that, right? These are the two conditions, right? These are the two things which can happen. Now, when you calculate the middle value, this middle value, it can happen in this case. The first section is not sorted, but the second section, my friends, is sorted. The second section is sorted, right? But in this case, the first section is sorted. What the hell? The second section, the first section is sorted, and the second section is not sorted. Now, when you are here, either the element is this one, but if it is not, figure out which section is sorted, this one or this one. Let's say this section is sorted, right? So I wanted to find x, right? X is, let's say, of this y height, and x is somewhere here. So we figure out whether x is coming from x is somewhere between mid and end, and if it is true, you go to the right side, not the left side. Okay, so look at this piece of code. If the second section is sorted, the drawing which I just created, the second section is sorted, what you're doing is you're figuring out whether x actually is between the range of nums mid and nums end. If the target or the x is between the range of nums mid and nums end, then you go ahead and search in mid plus 1 and end. Otherwise, you go ahead and search in start to mid minus 1. So bunch of things are happening. Start greater than end, less than, in that case, no solution, minus 1. Create a mid, which is the middle value. Now middle value can be target, right? If middle value is target, you return mid. Simple, very simple. Okay, let's jump to one more question. But before jumping to one more question, I want to discuss this question with one more approach. Okay, so the sorted array you have again. So it's 7, 8, 9, 1, 2, 3, 4, 5, and 6. So this is it. So there is a younger brother or a cousin of this problem, which we call find pivot. What is a pivot? What is a pivot? So pivot is basically the element. Pivot is basically the element which is smallest one in this array. Why are we so focused on pivot? Because this is the pivot. Once we find this pivot, we figure out that this particular part is sorted. Oh, just a second. Once we find that pivot, we know that this part is sorted, and we know that this part is sorted, right? So it becomes easy to do a binary search, because once you know pivot, you say, hey, do a binary search in the second section and do a binary search in the first section. And if you're finding it, then fine. Otherwise, go ahead. You're getting a point. So pivot is important because it gives you an idea of where is the point of inflection, right? It gives you a point from where the rotation is happening. I mean, the first section is sorted rotated, second section is sorted rotated. Correct? Is this clear? So a smaller, younger brother or cousin of this problem is to find the pivot. Let me just explain it to you how this works. Okay, exactly. So you just have to check for mid plus 1 and mid minus 1, something like that. Let's say it's 7, 8, 9. Not, let's call it 17, 18, 19. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's say you have an array something like that, which has index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so what you do is you try to figure out the middle value. So the start is 0, the end is equals to 13. You find the middle value, which is 0 plus 13 by 2 is 6, correct? So you go to the sixth element. You say, hey, you're the sixth element. Are you greater than the element before you? 3 is greater than, the value of 3 is less than 4. So definitely this is not an inflection point. I mean, for inflection to happen, the current element and the next element, the current element should be greater than the mid minus 1, basically, should be greater than mid element, correct? That's how the inflection is going to come. So for 1, this is the inflection point, right? 19 is actually bigger than 1. That's how we know that 1 is the inflection point. But in this case, there is no inflection, right? Since there is no inflection, what are we going to do? We are going to say that, hey, this is not the inflection point. Now figure out whether the inflection point lies here or whether the inflection point lies here. How do you know that? Again, simple purana wala formula. Just figure out whether the first segment is sorted or the second segment is sorted. Given the fact that the first segment is the second segment is sorted, 4 is less than 11, you know that I'm not going to find the pivot here in this particular piece. I'm going to find inflection in this piece, correct? And that's how you're going to keep trimming your array till it becomes till you reach to the point where the inflection is, right? Yes, you can also do for mid plus one. Yes, definitely. You can do for mid plus one as well. Yes, you're right. Sometimes it can happen. Let's say you reach at 19. How do you know that the next element is the pivot point? In that case, you know that 18 is greater than 19. That's happening, but 19 is also greater than 1. I mean, my bad. I'm saying 18 is less than 19. This is happening, but 19 is greater than 1. That means 1 is the inflection point, my friend. So what you do is, at every point of time, you check whether the middle element is greater than, oh, my bad, is less than mid minus 1. Correct? If mid minus 1 is there, my friends, if this condition is true, that means mid is the inflection point. Correct? But second condition, this is the first condition. Second condition which you check, if mid is greater than mid minus 1, but mid is also greater than mid plus 1, right? What if mid is greater than mid plus 1? What will happen in that case? Let's say your mid comes here, right? So in that case, mid is greater than mid plus 1. That means you know mid plus 1 is going to be your answer. In this case, mid is going to be your answer. The only difference between this approach and the previous approach is that it takes log of 2 times log of n times. Nevertheless, it's the same, right? So either it's log of n or it's log of 2n. It's up to you how you want to solve that. But I've told you about both of the problems. Oh yes, okay. I'll just explain you the concept. What is a Bitonic array? Okay. I'll not write the code for this one, but let's just see what it is. So there is something called Bitonic array. Bi matlab two, tonic matlab tone. So it's coming from bi plus tone. 2 tones. What are the tones? Tones is either ascending and descending. So there can be some arrays which first increase then decrease, right? So there is one peak element there. So it can come that you are given a Bitonic array. You just have to find out the maximum element of the Bitonic array, or this peak point. It can also be done using the same similar kind of approach which we have discussed. It's just that you have to put some, yes, exactly. This is exactly like finding the pivot. There will be some changes of the code, but you have to figure that out, right? For example, I mean, I'll just give you an example, right? So let's say this is what's happening. Let's say this is your Bitonic array. What you do is you go to the middle. You say, hey, is the middle element the peak element? Check from the previous. Oh no, it's a bigger value, so it cannot be peak. So you have to go to the second section, right? Calculate the middle. Are we there yet? I mean, is this the peak? Answer is no, because the element just before that is still more. Upside down. Okay. So let's say I calculate a middle like here. Okay. Is this the peak element? Answer is no, right? Why? Because the element right next to it is bigger. So once you reach here, once you reach the peak, you know that the element, once you reach this position, you know that the left side and the right side both are going to be less than the peak element. That's how you know that the peak is reached. Okay, so this is the code with Bitonic one. Okay, let's do one last question. Okay, so this is the third problem. It says that given an integer array, you are given an integer array, return all the triplets num I, num j, and num k, such that I is not equals to j, I is not equals to k. Basically, all these 3 elements are distinct. Okay, the indexes of these 3 elements are distinct. Indexes, not the value. And the sum of these 3 elements, num I plus num j plus num k, is equals to 0. Okay, question clear? Chalo. So this, let's think about this question. So you're given this array, all right, and you have to return all the triplets, such that the sum of the 3 triplets, ai, aj, and ak, comes out to be 0, right? This is what we have to do. So how can we solve this problem? 0, 1, 2, 3, 4, 5. How can you solve this problem, guys? So let's do one thing. एक काम करते हैं, सबसे पहले अपने इनपुट को सॉर्ट कर लेते हैं, ठीक है? So if I sort my input, what is going to become? It's going to look like -1, -1, 0, 1, 2, and 4. Remember that in question, the author did not the solution set must not contain duplicate triplets. So it's -1, -1, 2. Okay. Yeah. Okay. So it's not asking for indexes. Okay. It's not asking for indexes. It's asking for. Oh, is it -4? My bad. Thanks for telling me. It's -4. Okay. So the person is asking for just the values and not the indexes, correct? So let's solve this problem. How can we do that? Okay. Let's try to solve this problem. So first, let's pick -4. Okay. Let's say -4 is the first element which I picked. Let's say -4 is the part of my triplet. If -4 is the part of my triplet, what should this return? It should return +4, right? Correct? It should return +4. So I have to find two elements from this particular array such that the sum of those two elements is equals to how much? 4. Correct? That's how it's going to work, right? So now my problem of finding triplet sum has been reduced to finding what? Two elements such that -1, -1, 0, 1 and 2, correct? Now my problem is reduced to finding the elements, finding two elements such that their sum is a given sum. For example, this is, let's say, x, so you have to find -x, correct? The problem is reduced, right? So now it becomes more easier. So what you do is, let's do one thing. Let's pick this element. Let's pick this -1 element. Now what you can do is you can use map. I think you can use map, that's fine. You can use 2 pointers as well. Now the question is, either you can use a map or you can use 2 pointers. It's up to you how you want to solve it. Let's first try to figure out how can I solve this sum problem, all right? So let's solve this. I totally forgot what the inputs were. -1 and -1, I think 0, 4. I think I wrote it right. 0, 1, 2. Okay. So now we have to find x is equals to +4 from two elements. Okay. Let's look at it using a rational way. How can I solve this problem? So I pick this element. Let's say this element is the part, right? So what we want is x plus y is equals to, let's call it target. Okay. Let's call it target. X plus y is equals to target. Okay. So we have to find two elements such that it is equals to 4. If first element is equals to -1, my friends, what's the value of second element? What's the value of second element which you have to find? This has to be what? This has to be +5, right? This has to be +5. So you have to figure out whether through the binary search, whether this 5 is present in this particular element or not. Simple binary search would do, right? If 5 is present, you got your answer. If 5 is not present, you still have to look. Okay. So I know that -4 can definitely not be the part of solution. Then I try to fix -1 as input, -1 as the next input, and then I try to go to -1, 0, 1, 2. I have to find +1 from this array. I have to find +1 from this array, two elements such that the sum is equals to +1 from this array. Okay. Now, if I pick the first element is equals to -1, what's the next value which I have to find? +2 for it to make +1, correct? So is +2 there? Answer is yes. And if you do a binary search over here, you can find the solution in login time. If it's not there, you have to repeat it for some amount of time. So that's how you're going to find the solution easily. Okay, let's write the code for this one. I'll start writing the code for this one, and then we'll see. So, acha, one more thing. I always end up forgetting that, but just think about this one. Okay. So whenever you're writing code, writing the dry test cases for that code is also very, very, very important. Okay. Why am I saying that? Because as a software developer, you are, you have to make sure that your code runs in sunny days, good days, but you also have to make sure that you are able to figure out what are the different cases in which my code will not work. That's why I suggest you guys to think about corner cases before submitting your code. Okay, if the compiler is telling you, or if the online judge is telling you that this particular case will not work, then you did not think about the problem clearly. Okay, so your function is going to be, so I'm going to return vector of vector, right? All the triplets, right? Vector of vector, and let's call it triplets, and it takes into input vector int address nums. Okay. Now, one thing, if you are trying to find the triplets, but the number of elements are less than equals to 2, you may as well return an empty one, correct? Because it does not, triplets are not going to be there. Next, let's do one thing. Let's sort the results. Okay, so sort nums dot begin and nums dot end. So one more thing, I have not taught you guys about these library functions, right? But I expect you guys to know these library functions. So one more thing, okay? There are two things which you must know. So first thing is, okay, so a couple of things you should know. First is, so a couple of things which I should want to tell you. The first thing is these library functions, like sorting functions. They take what as input, you should know, right? So in case you want to do sorting by ascending order or by descending order, you should know. And this sort function I'm going to use for all the data structures you can think of, generally vectors, but yes. So you should know how can you sort a particular priority queue, how can you sort a particular element, I mean things like that. So one thing is you should know about that. Second thing is writing a custom comparator. What is a comparator? So basically, suppose you want to, I mean, there is a class called employee. Okay. An employee class has employee ID, employee name, employee age, employee salary, and things like that. Now I want to sort. Yes, again, I'm coming to that, buddy. Now I want to sort 50,000 employees I have on the basis of how much age they have, or on the basis of how much salary they earn, right? Let's say I want to do that. So how can you sort employee like that? How can you specify that, hey, I want to specify on the sort on the basis of age? In that case, comparator comes into picture, right? So the comparator you can write is, I mean, you can just Google it. Let me just Google it for you. Yeah? Writing comparator for C++. Okay. Yeah, in C++, whatever. Custom comparator function. So if you just Google it and figure out how to write a comparator, it's right there. I mean, how can you check or not? It's right there. Just read this through and you will know how to do a sorting. Sometimes people get stuck and I end up thinking whether they have actually understood the C++ concepts or not. Okay. So you can think about that. I mean, just take your time. Let's jump back to the code. So I've sorted the input array. Now I'm going to create the result, vector int result. Okay. For int I equals 0, I is less than nums dot size minus 2 I plus plus, because at least 2 elements should be there. Okay. So let's call it int current 1 is equals to nums I. I'm going to create 3, current 1, current 2, and current 3. Okay. This is done. And then I create int start is equals to I plus 1 and end is equals to nums dot size minus 1, correct? Okay, let's try to figure out that. So while start is less than end, see, I'm doing it using 2 pointers. Int mid, not 2 pointers per se, but yeah, sort of. Start by 2. Okay. Now if, take a look at this part. If current 1 plus nums start plus nums end is equals to 0. If this condition is met, result dot push back. What are you going to do? You're going to push these three elements, current, nums start, and nums end, right? Okay. Current 1, not current. So now what you do is you increase the start plus plus, you decrease the end by minus minus. Okay. Now while start is less than end, if the above condition is met, it's fine. If not, it will come here, right? And nums start is, now we have to remove the duplicates, right? We do not want duplicate elements to come, right? So keep moving till the start is equals to start minus 1. If the previous element is same, we do not want to consider it again, so I'm going to move the start to plus plus. Similarly, if while start is less than end, same condition for the last part as well. If nums end is equals to nums end plus 1, in that case as well, my friends, what you're going to do is you're going to reduce the end, correct? Else if what's going to happen is, there are going to be three conditions here. Either it can be 0, or it can be less than 0, or it can be what? Greater than 0, correct? If it is less than 0, what are you going to do? If it is less than 0, you increase the start plus plus. If it is greater than 0, you decrease the end. And that's how you're going to write the code. And if this is clear, small modification, which is if I is less than nums size minus 1, and now this is just to remove the repetition. Okay, you know what, I'll just explain it to you after I complete writing this code. And once this part is done, you just return result. तो देखो इस कोड का ना पहले मैं यहाँ पे ड्राइंग करता हूँ, उसके बाद मैं बताता हूँ कि what am I doing. Okay, so let's think what happened. Let's say this is the input 1 1 2 minus 1 minus 1. Oh, shoot. Let me write a good solution. Minus 4 minus 1 minus 1 0 1 2 3. Let's say this is it. Okay, I know it gets a bit loopy, but just bear with me. I'll explain it to you right now. Okay, so first of all, what we do is we pick this first element and call it current 1. Correct? This is the current element. Oh, just a second. We call it current 1. Now we try to find plus 4 from here, right? This is the second thing which we do. So let's just focus on this part. Minus 1 0 1 2 3. Okay, so next what I do is I create two variables. Current 1 I know is equals to minus 1. Okay, I created two more variables. Start is equals to I plus 1, which is, let's say this I is equals to 0 right now. Start is equals to I plus 1, which is 1, and end is equals to this last element, which is 0 1 2 3 4 6. Okay, end is equals to 6, which is nums dot size minus 1. So now your start is here and your end is equals to here, right? So again, three conditions can come. Current 1 plus result at start plus result at end It can be equal to 0, it can be less than 0, or it can be greater than 0. These are the three conditions which can happen, correct guys? If it is equals to 0, if it is equals to 0, what are you going to do? You're going to push this result, current one nums n, nums s, and nums e in the results vector, and you're going to increase the s by 1, decrease the e by 1. Why are you doing that? Because these values can be duplicate, right? We do not want to we do not want to include them again. So now my start is equals to 2, and my end is equals to whatever the value, 5, correct? Again, now check, are these values giving you the result? If not, if the value is less than 0, in that case, what's going to happen is you're going to increase the value of s. If the value is less than 0, you're going to increase the value of s. If the value is greater than 0, you're going to decrease the value of e. And if the value is equal, push the result, s increase, e decrease, right? This is exactly what we are doing in the code. Let's see how it's happening. Okay, so look at this part of code. First, we are going to all the elements, pick a current one, select a start and end, I plus 1, and num size minus 1. Okay, itna clear hai? After that, it's simple 2 pointers binary search kind of approach. What it's going to do is create a start less than end. Okay, 2 pointers approach. What it's going to do is checking whether that element is equals to 0, whether that element is less than 0, and whether the element is greater than 0. These are the three conditions I've written here. Is this not right? Correct? So if it is less than 0, increase the start. You increase the value from the start because start contains element in increasing order, correct? So you want to increase the value of num start, right? If the value is greater than 0, you want to decrease this result. So what you do is reduce the value of end. So end becomes end minus minus. And if the result is equals to 0, now this part is interesting, my friend, because now you have gotten one result, right? So you push that result in. So push the 3 triplets in the result. Increase the start by 1, decrease the end by 1, and remove all the duplicates from the array. I mean, it can happen, right? The next element is -1 as well, and we do not want to consider that because we have already considered that. So you may want to remove that. This condition can come in case something like that. Suppose this is the input, -1, -1, 0, 0, 2, 2, and I am finding x is equals to 1. Now this input and this input are giving me the correct result, correct? And I move start here and I move end here, but these components are also giving me the same result. But friends, this is a duplicate. Now this is a duplicate. -1 and 2 are already in my subset. I do not want to consider them again. That's why I have written 2 while loops to get rid of all the duplicates from the start and from the end. The time complexity of this code is going to be, this loop is going to run for n time, and the loop outside is also going to run for n time. So it's going to be n square.